And now, the part you've all been waiting for, part 5, the end of all things. I believe that children are our future. And I also believe that also robots. And so children and robots are our future. So what do I mean by this? Well, you remember last time we talked about the browser and the wonderful things that are in the browser and the terrible things that are in the browser. The worst of all of the things is its security problems. In particular, though, the worst of all of its security problems is the so-called cross-site scripting attack, or XSS. It's not called CSS, because that would be confused with the crappy style sheets system that's in the browser. And it really shouldn't be called cross-site scripting either, because there are modes of this attack which have nothing to do with operating across sites. You can have one of these attacks happening within a site. What it really is a confusion of interest attack. One thing that's unfortunate is that the security experts who identified and named it got it wrong and have not corrected it since then, and expect all the web practitioners to be adopting their broken jargon. So we're going to talk a lot about these classes of problems and how we're going to fix them. So why is it a problem? So what happens if an attacker can execute one of these cross-site scripting attacks and get some script onto your page? What can he actually do? What's the real hazard here? The attacker can request additional script from any server in the world. There's a thing in the browser called the same origin policy. It puts absolutely no restriction on this. So with just a little bit of script, just enough to create a script tag, or it could even be a little bit of HTML that creates a script tag, you can then load megabytes of additional programs. The page will not be notified that this initial programming is put in, and the page is powerless to prevent it from acting. Once the evil script gets its foothold, it can obtain all the script it needs to do whatever it wants to do to you. The attacker can read the document. The attacker can see everything that the user can see. In fact, the attacker can see things that the user cannot see. He can see the comments in the HTML. He can see all of the scripts. He can even see the hidden fields that you have, which are keeping the secret authentication, which allows you to communicate with your server. You can see your cookies. You can see everything. The attacker can then make requests of your server. If your connection is secured over SSL, which it should be, he gets access to that secure connection. If you are authenticating your requests by having crumbs or some other token of authentication, he gets access to that too. There's absolutely nothing the server can do to distinguish between one of these illegal requests and one of your own script's requests. Worse than that, if your server accepts SQL requests from the browser, then you have given the attacker direct access to your database. Now, if you're creating SQL queries, inserting code that comes from the browser, you may also be doing the same thing. It seems that SQL was optimized for SQL injection attacks. The attacker has control over the display and can request additional information from the user. So one common technique to try to prevent these sorts of attacks is whenever something important happens, ask the user to type in their password, because the attacker doesn't know that. But the attacker has absolute control over the display and can ask the user, what's your password? If you're on a site that has passwords and you tend to ask the user a lot for the password, then they've been conditioned to give it up at any time. Now, the browsers now have a lot of anti-phishing Chrome, and unfortunately, most users don't pay any attention to that. But if they are paying attention to it, it will tell them this is a legitimate request, that this is a page that came from the site that they thought they were on, so they should probably do whatever it tells them to do. The attacker can then take the information that he has obtained from the user, from your server, from the page itself, and send it to any server in the world. Again, the same origin policy does not prohibit this at all. The browser does not prevent any of these things. These are not due to bugs. There are obviously lots of bugs in browsers, and there have been security problems because of the bugs, but I'm not talking about bugs tonight. The web standards require these vulnerabilities. If you don't have these vulnerabilities in your browser, it is not standards compliant. So there's something deeply, deeply wrong with the standards of the web because they not only allow this stuff, they require that we have this vulnerability in everything that we do. The consequences of one of these attacks can be horrible. We can see real harm to our customers. We can experience a loss of trust, which is really bad for business. There could be legal liabilities. In some cases, it can even be criminal liabilities. And again, there is not a lot we can do about this. It's inherent in the browser platform. HTML5 is in no way a solution. I think HTML5 is a big step in the wrong direction. They not only do not correct this problem, they make it significantly worse. And they do that in two ways. First, they make the browser a much more complicated platform. And complexity is a tool of the enemy. So we should actually be looking to simplify and normalize, regularize the platform. HTML5 does not accomplish that. Two, even worse, HTML5 amplifies the rights that the attacker gets. So the attacker, in addition to doing all the other stuff we've talked about, is now able to get at your local database and can pull all the information out of that or modify it in any way that he wants to. He now has the ability to do some more extended forms of network communication and inter-process communication. So for all those reasons, I strongly believe that HTML5 in its current form should be abandoned, and we should start over with a new set of design rules specifically intended to solve the cross-site scripting problem, and then to enhance the browser to make it more competitive with the other platforms as a secondary goal, but that has to be secondary to the primary goal of making this a safe, reliable platform. I don't think the current HTML5 effort can be moved into that direction. I think it's too late. I think the best thing to do would be to start over. There are some good ideas in HTML5, and I think the Reset project could mine the current proposal for what good ideas it has. But I think the best thing would be to start over. So this problem has been with us for a long time. Cross-site scripting attacks were invented in 1995. And we have made no progress on the fundamental problems since then, except for one baby step that we made in December of last year. And in a little bit, I'll talk to you about that. So why do we have cross-site scripting attacks? What are the causes of that, and why is this such a difficult problem to fix? There are a number of causes. I mean, any serious problem has more than one cause. The first is that the web stack is too complicated. We have a lot of languages in the web. We've got HTTP, HTML, CSS, URLs, JavaScript, and a lot more. And these languages each come with their own encoding, quoting, commenting, and escapement conventions that are all different across all of these languages, and they can all be nested inside of each other. And on top of that, the browsers do heroic things to try to make sense out of malformed content. Adding all of these together mean it's surprisingly easy for a villain to put bad stuff into an HTML document or into user-generated content. And it's very difficult for us to discover it and keep it out and keep everybody safe. The last one, the bit of false heroism, sometimes that's blamed on the browser makers for working too hard to try to make sense out of stuff. I think the blame should actually go to unprofessional webmasters, particularly the first generation of them, who could not write correct stuff. And so during the browser wars, the browser makers competed by seeing who could make the most sense of all of this crappy coding, and in doing that, increase their market share, because the amount of bad coding out there was significant enough that capturing it was apparently a beneficial thing. Another factor is our reliance on template-based web frameworks. I think they're optimized for XSS injection. This includes things like ASP, JSP, PHP, pretty much anything with a P in it, you're asking for trouble. It's possible to do stuff correctly in all of those systems, but the defaults are against you. So it's easier to do things wrong than to do things right, and that's a recipe for disaster. Another cause, perhaps the biggest, the most fundamental cause, is the JavaScript global object. It gives every scrap of script in the page exactly the same set of capabilities. So JavaScript confuses the interests of your script with all the other script that's running there. Now, as bad as the browser is at security, it is better than everything else. Everything else is worse because everything else confuses the interests of the program or the site and the interests of the user. Desktop, absolutely. The browser understands that those are two distinct things and keeps them straight. Nobody else does that, or at least not very well. Where the browser got it wrong was it failed to anticipate that there could be additional interests in the page than just the user and the site. And that's the place where it fails. Then to complicate that, there's the mashup problem. Mashups are wonderful things. A mashup is the combination of programs representing multiple interests. And the browser confuses those interests. So an advertiser on a page gets the same privileges as an AJAX library or an analytic file, which get the same rights as the main application and any of those XSS things that somehow got onto the page. Everybody gets the same set of rights. So it's impossible for any of those components to defend itself from the other components. This is particularly troublesome in the case of advertising because advertising is a self-inflicted cross-site scripting attack. Mashups are a self-inflicted cross-site scripting attack. I think mashups are the most interesting thing to happen in programming development in many decades. So it's important to get this fixed. Fortunately, we have made some progress on this in the safe JavaScript subsets. Two of the best known of these are Caja, which was developed at Google and is being used very extensively at Yahoo, and my own AdSafe system. The thing they have in common is that they are attempting to keep guest code away from the global object. If the guest code can't get at the global object, then it will not be able to do all the bad things that I described. And Caja and AdSafe take different approaches to accomplishing that. Caja is a transformer. So it will rewrite your JavaScript into different JavaScript, which has different properties, which will have runtime checks put around certain dangerous things in the language, which will insert doppelgangers into the system. So you think you're talking to a global object, but you're actually talking to something that's benign. Caja is a wonderful system, but it comes at a performance penalty, and also it's difficult to debug because the code you're actually running may not look very much like the code that you wrote. AdSafe takes a different approach. AdSafe works with static validation and removes features from the language which are difficult to verify statically. It turns out most of the language is preserved, but you lose the ability to use this, and your ability to use subscripting brackets is greatly curtailed, which is really annoying. So we have these two systems that are available that give us a partial solution to the security problem. But last December, we did better. ECMA formally adopted the 5th edition of ECMAScript, hooray, and it contains a new mode called strict mode. Strict mode allows us to do a very nice thing. Strict mode makes it possible to have static verification of third-party code without over-constraining the programming model. So you get the best of both Caja and AdSafe in that you've got the full use of the language that Caja permits you, but you run with the same speed and same convenience as you do with AdSafe. So this is a really nice thing, except it doesn't do us any good unless everybody is running on ES5 strict, and it's not in the market yet. Now, even having that, there's still a lot of work left to do. ES5 strict can protect the page from its widgets, but it cannot protect the widgets from the page. This is important in applications where you want to put advertising and put it on any website and be confident that the website is not going to do something bad to the ads or suppress the ads or engage in click fraud. Right now, there's no way to do that. ES5 strict cannot protect the page from cross-site scripting injection. So that danger is still present. And ES5 strict is an important step toward a programming model in which multiple interests can cooperate for the user's benefit without compromising each other or the user. Important step, but not a sufficient step. So the browser makers are now in a race to implement ES5 strict. It's not clear who's in front yet, but I'm hoping that they start emerging in the marketplace soon. On the day when all 5 major browsers support ES5 strict, IE6 must die. I don't want to sound repetitive, but it's really important that we kill it. We get absolutely no benefit from ES5 strict if we still have to be backward compatible with browsers that are broken. So somehow we have to figure out a way to say goodbye to these guys. So many people get discouraged when you talk about security because so many popular approaches to security fail. They just fail. For example, there's security by inconvenience, which I'm sure you've seen practiced at the airport, where they put us in corrals like cattle and run us around. And it's proven that that is not an effective security mechanism, but they do it anyway because we've got to do something. You know, we have to at least put on a show that we're making you safe that makes people feel better. So it accomplishes that maybe, but not much else. We've tried security by obscurity, where you try to make your system so complicated that the attackers can't understand them. That doesn't work. We've seen people try to inject speed bumps into the information superhighway, with the thinking that that's going to slow the attackers down. It doesn't. We've seen a confusion of security with identity, that if we know who wrote the code, then that tells us something about how safe it is to use. That turns out to be completely useless. So what we're left with is security by vigilance. And that doesn't really work either. So what we do here is we've got some very, very smart people who've been studying the corpus of things that are wrong with the browser, which is huge, and understanding it fully and keeping up to date on it, and then communicating that information back to our developers. And it turns out it's just too much information to handle. It's way too complicated, and the process of transferring that information to developers who already have enough to do is really not effective. But at the moment, that's the state of the art. That's the best we know how to do, and it is just not good enough. So I think we can do better. And the solution to doing it better is actually already in JavaScript. JavaScript gets beat up for its security problems, but it is actually closer to being a secure language than virtually any other language out there. You just have to recognize the pattern and make it work. So I'm going to show you some examples of how to think about this. And this is the sort of stuff that's within Caja and AdSafe, but it's already in the language and just needs to be exposed. So JavaScript is a pass-by-reference language. That means that when you pass a value to a function, you're not passing a copy of it, or you're not passing the name of it, you're passing a reference to it. And in the old speak, that would be a pointer. Sometimes it's a little confusing when values are immutable, as some JavaScript values are, and that pass-by-value and pass-by-reference look the same. But JavaScript is a pass-by-reference system, as most systems are today. So in a reference system like this one, you get effects like this. So we've got a variable named variable, and I initialize it to an empty object. And I've got 2 more variables, A and B. I assign variable to both of those. And then I test for equality. Now, equality will be true only if A and B are the same object. It will be false if they are identical objects. And in this case, anyone guess what it's going to do? It's true. They are the same object. So A and B are not copies of the variable. They are the variable. They are the value that the variable references. They all contain exactly the same thing at this instant. It's important to understand this because people often get confused between values and variables and misunderstand what their relative roles are. So let me show you an example. Here I've got a little function called funky, and it's a silly function. It takes a parameter called O, and it assigns null to it. Okay, not a useful function, but there it is. Then I create a variable called x, and I assign an empty object to it. And then I call funky, passing x. So after I do that, what will the value of x be? Who thinks it's going to be null? And who thinks it's going to be an empty object? It's going to be an empty object. And the reason is we're passing to Funky the value that x had. We're not passing it x. So Funky knows nothing about x. All Funky knows is that he was passed an object. And when he does the assignment, what he's doing is replacing what his O points to from the object that was passed in to the null that he replaces it with. All of that happens completely independently of x. This is a really important thing to understand about the language because all of the security properties I'm going to talk about later derive from this. So let me show you one more example. I've got a swap function where I pass it a and b, and using a temporary variable t, I will swap a and b. And then I'll create two variables, x and y, and initialize them to 1 and 2, and then call swap. So after I do that, what will the value of x be? Will it be 1 or 2? 1? 2? Good, nobody's hand went up that time. The answer is 1, because again, swap doesn't know anything about x and y. Swap only knows about the values that they were associated with. It doesn't see the variables themselves. So this confusion about variables and values can lead people to writing really bad code. So here I've got a function called doIt. It will take some inputs and do some useful thing with them and compute a result. And when it is done, it wants to assign the result to the variable whose name was passed in. And there are a couple of ways you could do that. Both are really bad, which is why they're in red. One is you construct an eval where we take the name and concatenate it with an equal sign and the result. And that's just so awful. Nobody ever do that. If you ever find yourself writing code like that, seriously, step away from the machine. Okay? Another alternative, which is not quite as totally awful, but is still very awful, is to recognize that the window is the alias of the global object. And so you can find any global variable in there and do the assignment there. That's bad for a number of reasons. One is you really shouldn't be messing with global variables because they're evil. And the other is that if you really want a structure in which you can have names and refer to names by looking them up, what you really want is an object. And JavaScript is really good at that. And you can use the language well in that way. So another way that I could write doIt is I will pass in the object and the name, and then I can do it the right way. This is in pink because it's still not good, but it's a lot less bad than the previous one. It's still too obsessed with trying to change something that doesn't belong to it. So even though it's passed in, there's a bad information hiding property going on here. So a better way to write this would be simply return the result, and then the guy who called can decide what to do about it. Sometimes that's not the right way to do things, particularly if the result cannot be determined immediately. For example, if the result depends on going to the server and getting some more information, or if the result depends on waiting for the user to do something, then this kind of pattern comes closer because you can't lock up the browser waiting for those things to happen. So another way you could write this, and this is the right way to do it, is to have a callback. So in this case, I will provide a function which should be called at the time that we're ready to produce a result. And the function will obtain the result as a parameter and do something useful with it. doIt doesn't know what it's going to do, but it provides that service. This has some really nice security properties. For one, doIt cannot get at whatever is stored in the callback. So the callback is a function. It has a closure. It's closed to doIt, so it cannot see what's going on, can't get at my object. So that's really good. So I can give it this token, this function, which allows it to do something useful for me without giving away the farm. That's a wonderful thing. Also, because JavaScript is lexically scoped, the callback function cannot get access to doIt's local variables. It cannot steal any information from do it. It can only get the stuff that do it explicitly passes into it. That's really good too. That's a basis of a secure system. And that's where we're going with this. So having that, I can now call do it, and in my call I pass the inputs, and I pass a function. And one of the things my function could do is take the result and assign it to my object block. So there's no way that do it can find out what I'm going to do with its result. All it can do is deliver it to me. So that's good. We've got the information hiding happening in a really nice way now. Now, if I'm going to be doing this a lot, if I'm going to create a lot of these callbacks that just do a simple storage into an object, I can automate this a little bit. So I'm going to make a function called a storer, which will produce a function which will do that other thing. So I pass to the storer function the object and the name of the parameter or of the property that I want to set, and it returns a function which will do that when it's called with a result. And because of closure, it's going to keep track of the object and name, and they will be hidden from to it. So that's pretty handy. And then I can call it now by calling do it and passing the inputs, and then passing the result of calling the storer on the two things. Everybody with me? Now, if we find we're doing this a lot, for example, we're doing a lot of stores to the same object, we can automate this a little bit more. So I'm going to make a storer maker. I will pass to it an object, and it will return to me a storer which already knows about that object, so all I have to pass in when I call it again is the name. So down at the bottom, I make my storer, which is an instance, or the result of calling the storer maker with my object. And then I can call do it now, passing again the inputs and my storer, blah. Okay? And you can get as intricate as you need to with this stuff. So you have sort of the nice property that you can, to a large extent, create the programming language which is perfect for writing your application, where you can sort of embed all of the things that you do inside of functions which allow you to describe the activities of your program in those functions. Suppose you, one problem with that is that do it could hold on to that function that I passed and use it again, perhaps sometime when it's not to my advantage. Maybe I don't want to allow him to do that, he can only store once into that variable. So I'll create a once function, and the once function will take a function and guarantee that, and return a function which wraps it, which guarantees that it can only be called once. If you try to call it a second time, you'll get a null exception and it'll fail. So there's a function, again, we're taking advantage of closure. When the function it returns is called, it nulls out func, and that guarantees that it cannot be called usefully again. So that allows us to have it called only once. And then I can take the result of storer and pass that to once, and now we've got a function that can only be called once. So doing this, I've made a pretty big change to what do it is able to do without changing do it, okay? Because none of this is do it's business. Now suppose I want to change the rules a little bit. Instead of allowing it to do it once, I want to allow him to change it as often as he wants until I decide you can't change it anymore. And at that point, it cannot be changed again. And so to do that, I create a revoker. And the revoker this time returns two functions. One of them is the revocable function, which acts similar to the way the once function did, and also the revoke function. And when you call the revoke function, it causes the revocable function to fail by removing its function reference. Okay, everybody still with me? Then some of the stuff I showed you on in Act 3, things like promises and things like sealers and unsealers also fit very well into this sort of pattern. So suppose I want to do more than one thing in response to what to it does. So I'd like to have a sequence of functions called. And I could just write a function every time that happens, but I can automate that too. So in this case, I've got a sequence function which takes a number of functions as parameters and returns a function which, when called, causes all of those functions that were passed to be called in sequence. So that would allow me to write it like this. So I'll call doIt, and I will allow it to once execute a sequence of calling that store, and then taking the result and calling alert with it. I can do that too because alert is a function, so I can pass it in as well. Okay? So this is all based on the idea of information hiding, where when we're designing our interfaces, we design them in terms of what does this guy need to know in order to do his work? And we'll give him that and nothing else. And that turns out to be a really good method of design. As David Parnass wrote a classic paper in 1972 on the criteria to be used in decomposing systems into modules. Highly recommend you read this paper. Really, really good paper on software design. Even though it was written a long time ago, a lot of it's still relevant. And in fact, the parts of it that are kind of dated now are dated mainly because he was right. At the time, people were doing a lot of design using flowcharting. That was sort of the state of the art, and Parnass said, no, flowcharting's bad. You should be doing this stuff instead, which turns out to be right. And eventually, everybody listened to him, so we don't do flowcharting anymore. So when you see the bit in his paper saying don't flowchart, it's not like, you know, it's old thinking. I mean, he's actually responsible for our knowing that. But we can take it a little bit further. He was talking mainly about data, but if we're talking about using a reference as a capability, we're now doing capability hiding. And we're giving powerful objects and functions over on a need-to-do basis. If you need to be able to do this thing, I'll give you the power to. If you don't, then you can't. And this is a simple to understand but very powerful way to build secure systems. So it's called capabilities or security or object capability security. And the key idea to remember in this system is that there should be exactly 3 ways to obtain a reference to an object. By creation, by construction, and by introduction, and by no other means. And these 3 ways of obtaining references are actually very simple. The first is by creation. If a function creates an object, it gets a reference to that object. I mean, it wouldn't make sense otherwise. So that one's sort of a given. Number 2, an object may be endowed by its constructor with references. So in the case of a function, things that it gets as part of its closure will be things that are capabilities that it receives by construction. Then the most interesting case is introduction. So here we've got an object graph. A has references to B and C. C and B have no references, so they cannot communicate. But A decides it would be useful to him for B to be able to communicate with C. So it wants to do an introduction. So it does that by calling B, passing C as a parameter. So in this case, B could be doIt, and A could be the function that's calling doIt, and C is that function that we're passing that's going to do the callback. Once that call is completed, B now has a capability to interact with C. A capability is just a reference to an object or a function which allows you to manipulate or call that function. If references can be obtained by creation, construction, and introduction, then you may have a safe system. And if references can be obtained in any other way, you do not have a safe system. And that's the state of the art right now with JavaScript. JavaScript is not yet a capability language because it depends on a global object. So if you know the name of a global variable, that gives you the capability to interact with that global variable. That breaks the laws of acquisition. So that's the thing that we need to fix. In fact, that's the thing that Caja and AdSafe do. And that's the thing that ES5 strict begins to do. If you'd like more information about object capability security, I highly recommend that you go see Mark Stiegler's talk, The Lazy Programmer's Guide to Secure Computing. He gave it, I think, 2 weeks ago at Google. Great talk, highly recommend it. Stiegler's an interesting guy. He's a researcher currently at HP. He's part of a loose federation of researchers from places like HP, Microsoft, IBM, Google, Mozilla, Yahoo, who are working on object capability systems and applying them to the web. In his career, he's a science fiction writer, a really good writer. He used to be an executive. Interesting fact about Mark Stiegler, he used to report to Carol Bartz, and he also reported to me, not at the same time. So I think he may be the only person to have reported to both of us. So go see it, but not yet. First we'll take a break. We'll come back in 10 minutes, and then we will resume. Okay, so let's resume. Let's talk about performance. Does that matter to anybody? Steve, you here? Aren't you getting tired of this? Huh? Okay, so performance. How do you make this stuff go fast? Or go acceptably fast? It's important when you're thinking about optimizing programs to think about optimizing your optimizing. You can very easily waste time in ineffective optimizations. And you don't want to be wasting time when you're trying to save time. So meta optimization, optimizing your optimization schedule is just as important as the stuff that you ultimately make faster. So this is one of the fundamental equations of performance. The total amount of time spent is equal to the cost per iteration times the number of iterations. And generally when we look at this stuff, we think C is the important thing. If we can drive C down, then everything is going to go good. And there are cases where optimizing C does help, but in most cases it doesn't. So for example, say you fill the memory of a computer with a whole bunch of instructions that contain no calls or loops and start at one end and see how long it takes to get to the other. On modern computers, that's going to go really fast, even on really big memories, because instructions just go quickly. So you've executed a lot of instructions, but you're ending up not creating a lot of time spent. So C was kind of negligible in that case. What's more important, or the more problematic case, is where you're looping or you're recursing. And so doing things over and over again, the cost of each of those iterations now becomes significant. And you think, well, okay, if I can find the places where I'm doing stuff over and over, make those go faster, then you're going to be better off. And often you are, but sometimes surprisingly you're not very much. One way to think about this is using the big O notation, which is often used to describe the behavior of algorithms and repetitive systems. It turns out that the N component often overwhelms the C component to the extent that often you can just completely ignore the C. And that's counterintuitive, but it turns out to be the case. So there are lots of different levels of performance that generally anything which is constant time is going to run faster than everything else. Anything which is logarithmic generally is going to be faster than everything below it, and so on. So in the case of linear systems, in that case, C can be important, but again, not as important sometimes as we think. For example, an array would be a constant, O1 operation. A hash table is usually a log n operation. A linear search would be a linear operation. Now, a linear search, say going through an array, will generally find what it's looking for about halfway through. So on average, you could say it's going to be n over 2. But that 2 gets factored out and moved into C, so it's just n. We don't think of O n over 2, it's just n, because the 2 turns out not to be very important. Then when we start getting up into the more complicated things, when we go log linear or exponential, C becomes almost completely irrelevant at that point. So if we're trying to to look at the performance of something that is n squared, if n is large, then c is insignificant. I mean, we can work really hard and try to cut c in half, but that's nothing compared to what n squared does. So that's counterintuitive. You'd think, okay, if we're going to go through that many iterations, then anything we can save on each of those huge numbers of iterations is going to be a big savings. It's all going to add up. But it doesn't work that way because you fail before you get to the point where you're going to notice the improvement. Because we have performance thresholds that not only does the computation have to complete, but it has to complete in a certain amount of time. And how much time it is depends on what our goal is. In the web, and doing stuff in browsers, generally the first three, the distraction, the frustration, and the session failure thresholds are the ones we worry about. So the distraction threshold happens at about, 100 milliseconds. If you're slower than that, then you tend to kick the user out of the zone, out of the flow, and just kind of make them stupid or less productive. Then at about 1 second, you start to experience frustration. Users might not even be aware that you're frustrating them, but they start getting irritable and perhaps making mistakes. And you don't want people becoming irritated using your stuff. So you want to avoid frustration. Then at about 10 seconds, you get failure. Some people will think, oh, it must be dead. I'll hit refresh or close the browser. Or in some cases, the browser itself will say, I don't know, it doesn't seem to be working anymore. Do you want to stop it or what? So it's really important that we keep below those thresholds. Then beyond that, you've got stuff where it becomes impractical. Like we want to compute some number that we're going to use every day, but it takes longer than a day to compute it. That you run into those sorts of things. At the high end, you've got impossible. And there are actually some algorithms which have impossible as a goal. For example, cryptography. You're designing a secret code. You'd like it to be, or it will always be possible to have a brute force attack, but you want the brute force attack to be so slow that you can guarantee that it'll practically never happen. And so it's a useful thing, at least theoretically. So to get under the distraction limit, it's necessary to give immediate feedback. So as soon as we get the event, we want to do something that's going to let the user know that we saw it. And we may not necessarily have the final result of the interaction, but they get enough feedback to know that we're aware of it and we're working on it. That has to happen right away. The next level up is frustration. Now in this case, we may be depending on a server round trip or perhaps multiple round trips. And then we're going to be passing through a lot of data, and we want to keep all of that small. And generally, the only way to get that to be small enough is to keep n small enough. Because if it turns out we have to go searching through stuff or fetching a lot of stuff, if there's a lot of material there, we're going to be too late. So we want to keep our working set generally very small, even at the expense of apparently unnecessary network round trips. We'd like to work with the caching system if possible. And it'd be nice if one of the things in HTML was a smarter caching policy to allow us to work that stuff more effectively. But generally, the key to that is going to be just-in-time data delivery, which is something that the Ajax platform is really good at, and we can take advantage of that. I highly recommend that you don't fiddle with code. It's really, the easiest thing would be to just go in and start changing things and hope that that makes things go faster. It's generally not very effective. It's what you need to do instead is to find where the time is being spent, because it can be counterproductive to speed up things where you're not actually spending the time. I'll show you some examples of that in a moment. So we think that every bit of waste we can squeeze out helps performance, and that turns out, surprisingly, not to be true. We need to squeeze it out where it matters and not where it doesn't. If we're optimizing code which is not consuming most of the time, then we're just wasting time, and we may actually be degrading the quality of the code, which could have consequences going forward. One surprising source of inefficiency in JavaScript is its implementation of arrays. In most languages, an array is a linear sequence of memory carved into equal-sized buckets. And you can find any of those by a number. That's generally a O1 operation, but not in JavaScript. In JavaScript, they're implemented as objects, and so objects can be implemented as hash tables, which means they're actually log n operations, which for small n can still be pretty fast. For large n, you start to feel some slowness. What's worse is that on IE, they didn't implement hash tables. They implement a linked list. So in order to find an item in an array or an object on IE, they have to do a linear search, which is a order n operation. So if you're doing that in a loop, which is a common thing to do with the elements of an array, a loop which should have been O(n) may turn out to be n squared. And so I've seen cases where a program is going a whole lot slower than anybody expected, not understanding why. It's because it's spending all of its time looking up things in arrays. I'm promised by Microsoft this gets fixed in IE 9. I hope that turns out to be the case. Eventually, I hope that we see all of the JavaScript engines eventually implement real arrays in JavaScript. That could help performance significantly. And I think a lot of the performance we're already seeing in JavaScript engines comes from exactly that. Another thing to watch out for is WOW. Very often you've got product designers or product managers who don't understand the value of the product. And they understand that people don't like it, and they don't understand why they don't like it. So instead, well, let's make it wow. So when you move over things, things start spinning and popping around, and you have to chase something with your mouse before you can click on it and that kind of stuff. That turns out to be extremely ineffective from a UI perspective. If it turns out that doing that stuff helps the user, helps them to discover, helps them to manage what's going on, then great. But if it's there just to show off, or if it's there just to distract them, it's a waste of time, and you shouldn't be doing it. But it can also cost a lot of time in your process. So you're trying to make things go faster for the user, but then you've got these little things which are completely extraneous and unnecessary, slowing things down, causing layouts and redraws and stuff completely unnecessarily. So you want to avoid that stuff as well. So I highly recommend that you not tune for quirks. There's still a lot of variation over the browsers in terms of where they spend their time and what sort of things they do quickly and what things they do slowly. And some of the browsers have very surprising inefficiencies. But it turns out that a trick that might make things go faster on browser A might end up going slower on browser B. And it's going to probably be more the case in the next generation because the performance characteristics of the new JavaScript engines are vastly different from the old ones. So I recommend that you avoid short-term optimizations, because in the long run, they're going to work against you. Don't optimize without measuring. If you don't know where the time is being spent, then you don't know where to speed it up. And very often, our intuitions are just wrong. It's difficult for a human to understand where a computer program spends its time, so you have to measure. One way you can measure is to go to date.now and get the current time, do something, get the time again, compare the two. I have to warn you, though, that this can be really unreliable because of the way clocks work in operating systems and gets amplified by the browsers. You can be off by 15 milliseconds or more. So in order to have results you can have confidence in, you may have to repeat the test many times. And sometimes even accurate measurements can lead to incorrect conclusions. So I was reluctant to show you this slide because while all of this is true, it could lead you to doing things which are going to be really unproductive. And this is why. So this is a chart that Microsoft showed at the Mix conference in Las Vegas recently, showing the performance of various websites on IE9 and showing where it's spending its time. JScript is the gray thing at the bottom. Now, if you could get really heroic with your JavaScript and make it go twice as fast, which I don't think you can, certainly you can't do that by fiddling with it, but if you could, most of these bars are going to be about the same height anyway. I mean, your users are just not going to notice it. A much more productive use of your time would be figuring out how to make the purple smaller. The purple is layout, and the triggering and management of layout turns out to be much more important in managing the performance of web applications generally than the speed of JavaScript. So it's nice that the JavaScript engines are all getting faster. It'd be even better if the other bars were getting faster too. And they're not in that competition yet, but I'm hoping that they will. For example, Microsoft announced that they're working hard on making rendering take advantage of hardware support. And I expect all the browsers will be doing similar things. So when that happens, the orange bars should shrink down really small. I don't think there's much they can do in hardware to fix layout. So that may be the next frontier in browser performance. So the problem we have is, looking at these bars, there's no way to know what you're doing in your program that's causing these bars to be the size they are. We see that they change relatively pretty significantly from one application to another, but how do you know what's actually causing those effects? We don't have good tools in the browsers currently that tells us how what we do in JavaScript affects the rest of the performance of the browser, except Speed Tracer, which is a brilliant tool available for Google Chrome. Just go to Yahoo, type in Speed Tracer, Google Chrome, and it'll take you right there. And then load it into Chrome and use it. It's a brilliant tool. You turn it on and run some stuff, and then it traces what's going on there, figures out where in the browser it's spending its time, and gives you these wonderful charts that describe what the performance of your application is and why and where it's spending its time. Absolutely a critical tool for doing performance in Ajax applications and browsers. It's absolutely necessary. We've got it in Chrome, which is great. This should be standard equipment in every browser. So we need to lean on the browser makers, everybody. We need to get tools like Speed Tracer. We need better visibility into where the browser is spending its time, because without that, optimizing our programs is pretty near hopeless. So where they're spending their time instead appears to be in making the JavaScript engines go faster, which is a good thing. When JavaScript first came out, it was optimized for time to market. It was built in way too little time, shipped. You know, the miracle was that it worked. It didn't have to be fast. It just had to work and get out there quick. But that was a long time ago. And since then, you know, they got cruftier as they fixed bugs and bolted more stuff on it, but they didn't really get faster. So it's very nice that Google's V8 project kind of put the fire under everybody and said, okay, let's go fast. And so they're now working on going faster. So you see IE8 being really slow. A lot of that, I think, is going to be array references, but who knows? And then the red one is what IE9 was 2 weeks ago, and they think they're doing really better. Now, are they doing better than Firefox? Are they not as good as Safari and Chrome? I have no idea. Nobody knows. Because this is the performance on a benchmark, and the only thing we know about it is that it is a very poor predictor of the performance of web applications. So it may be that if you're working on a JavaScript engine and you're making it faster for the things that you think your applications are going to be doing, and it also accidentally makes the benchmark go faster, then that's great. If it turns out that you're focused on making the benchmark go faster so you can be at the far end of a chart like this, then that's a really bad thing, because it's pretty unlikely that real applications are going to benefit very much from that. And then if you're developing one of these things and you're doing something that's going to make applications go faster and it doesn't move the benchmark, do you keep it in? Or if it makes the benchmark worse, you know, do you keep that in? So it's good that that the JavaScript engines are getting faster. Probably not going to make any difference for the current generation of web applications, because that's not where we're spending our time. If JavaScript were infinitely fast, most of the bars didn't move very much either. And while they're a lot faster than they were, they're not going to be infinitely fast. But they are improving, and so we'll see some benefit from that. The biggest benefit will be that there's going to be a whole new class of applications which are now feasible in JavaScript, where we can now think about managing bigger data sets than we were able to before because the engines are faster. So things like doing some 3D graphics in JavaScript now is just on the edge of becoming possible. So I recommend, instead of focusing on trying to make it go fast, maybe trying to make it clean and elegant. That good code, well, first off, if it does turn out that you need to do some heroic optimization, it's a lot easier to do it on good code than it is on bad code. Because you're going to change the code, and you hope you can do that without introducing bugs into it. That's a lot easier to do starting from good code than starting with bad code. But more than that, if you look at the way some of the new JavaScript engines work, they're doing tracing or they're doing observation of the execution of the program and doing just-in-time optimization on the instruction flow as it's happening. Having small, elegant programs is going to work much better in that process than big, crufty, splintered programs. So I recommend that you invest in high code quality. I think that's, again, thinking about this in terms of meta optimization, I think that's a very good use of your time. So tonight is a special night for me. I'm all dressed up, and the reason for that is this is a special anniversary for me. Tonight is my 10th anniversary with JavaScript. I wrote my first JavaScript program 10 years ago. I was the founder, CEO, CTO of a software company called Electric Communities. And we were contacted one day by Turner Broadcasting to build a children's online system for them. At that time, we were a big power in online communities. That's why we're called Electric Communities. And we had a chat system that they thought we could repurpose to their children's online collectible game. Turned out it didn't. I went to Atlanta and learned about their specifications, and our chat system just wasn't going to be good enough to do the stuff that they wanted. And so we were faced with the dilemma, well, how do we get this done? And to my team, it was obvious. They'd been doing Java from the beginning and said, great, let's build another Java system. Now, I have buried $20 million doing essentially client-side JavaScript. I didn't want to do that again. Client-side Java. It just doesn't work. So it was got to figure out another way or have to give the money back. And it was a lucrative contract. I didn't want to do that. In fact, this was the only money the company really ever made. So, so I don't know where it came from, but I got this crazy idea. Maybe I can do it in JavaScript. I'd looked at JavaScript when it was first announced and rejected it out of hand as the stupidest thing I'd ever seen, which maybe it was at the time. But 10 years ago, I took a second look at it and decided, well, okay, maybe I can do this. So I got Flanagan's book and looked for sample programs that resembled what I needed to do, and came up with a little demo where I did drag and drop of cartoon characters. And I took that back to Atlanta, and they liked it. So yeah, this is great. In fact, for something that's for kids, you can't really ask them to install software anyway. So this is actually a better way to do it. So I went to my team and said, okay, we're going to do it in JavaScript. And they said, great, what's plan B? And we should start that right now because there's no way this is going to work. I insisted it would, and so I sought volunteers for writing the JavaScript. There was no threat I could make that would cause these Java developers, really good developers, to write anything in JavaScript. Just would not do it. Fire me, please. I would die before I have to write JavaScript. So I had to do it. And I did it the way everybody else did it. I made every mistake that you can make. Mistake number one was I didn't bother to learn the language first. It looked familiar enough, I thought, I can puzzle this out. I've seen the sample programs, I can make this work. I tried to write in Java style, even though it wasn't Java, and I knew it wasn't Java. I tried to do it anyway and had some partial success at it, but it didn't work very well. And it would keep roundhouse kicking me in the head, and it hurt. And I remember getting so frustrated with it and angry. Once I punched a cubicle wall and almost broke my hand. It was like really painful. And then eventually I figured out what was going on. After a lot of struggle, I eventually figured out that it was a functional language. And at that moment, I stopped fighting it. And I remember when that moment occurred, I was bicycling. And I had just read the ECMAScript standard, which is a really difficult thing to understand. But I read through it, and then I had this epiphany when I was miles away from a computer. Oh, it's got functions in it. They're lambdas. I can do this now. And it completely changed the way I thought about the language. In the end, the story ended successfully. We finished on time and on budget. Turner shipped it, and everything went great. It's sort of a hobby project. I took a parsing technique from Von Pratt, top-down operator precedence, and implemented it in JavaScript just to show that it could be done, that it really was a functional language. And that turned out pretty well, and was like, oh, what do you do with that? And I turned it into a lint program. I didn't know that I needed a lint program, but I had the technology that you needed to make one, and so there I had it. And then kind of thought about, well, what do I do with that? So I started hanging out on comp.lang.javascript and listening to the things that people were complaining about. And the most interesting for me was when people would come on saying, help me, I wrote this thing and it doesn't work the way I expected, what's wrong with it? What did I do wrong? And so I would ask myself, could JSLint have caught this mistake? In some cases it couldn't because it was a logic error, but in some cases it was a not understanding the language or the language setting traps for you error. And it seemed like I ought to be able to deal with those. So in many cases the answer was yes, I can do something about it at the cost of some discipline. It means that you have to avoid using forms that look like errors. And if you have that discipline, then JSLint can help you write errors or programs that are much more likely to be error-free. So let me give you an example of that. JavaScript has a with statement, which can be extremely useful. And a lot of clever ninjas have found a lot of uses for the with statement. But it can also mask terrible errors. And so the question I had to ask was, is it possible in static analysis to distinguish between the useful cases and the terrible errors? And it turned out, no, it's not. So then you have to ask the question, is it really that useful? Can we live without it? Are there any programs that can be easily written with it that couldn't be written as easily or almost easily without it? It turned out, yeah, we can do without it. So then I classified it as a bad part. If it's a bad part, we'll get rid of it. We don't need it. And by not having it, it means I can now do static analysis and determine when it is causing problems for us. So I removed all of the unessential features and forms that cannot be distinguished from common errors. Turns out there are some essential features which also cannot be distinguished, and I had to keep those in. For example, the plus operator, sometimes it concatenates, and that's a really awful thing. But you can't take addition out of a programming language. That doesn't work, so that had to stay in there. So then I looked at what was left. After stripping all of these problematic things from the language, what have you got? Is it still complete language? And it turned out it wasn't just a sufficient language, it was a superior language. An understanding of what it was much easier to appreciate when you took out all that extraneous error-provoking junk. That you could see there are the objects and there are the prototypes and there are the functions, which are the heart of the whole thing, and how they interact together in a way that no other language had ever done before. And it was like, this is a brilliant language. This isn't the stupid thing that I thought it was when it first was introduced. It's actually brilliant, and it's actually leading everything else. It's not a subset of better languages. It's actually a superior language showing us, in my opinion, the way forward, the next big thing in programming. So my approach ultimately was language subsetting. And subsetting's been done for years, and there are a lot of reasons to do it. One of them is that you're too lazy to learn the whole language, and that's probably not a good reason to do it. A better reason, as I found here, was that there are problems in the language, that they're problematic, maybe design errors. And if you just avoid those, then you're going to have a much better time. And because of JavaScript's crazy rush to market, it has more of those, I think, than maybe any other language out there. But it cleans up really well. When you take all that stuff out, there is a wonderful language. So I'm on the the TC39, which is the committee of ECMA, which is responsible for the maintenance of this language. And we're all very aware of the problems, of all the bad parts and the awful parts. But we're pretty much powerless to fix it. It's because those bad parts are dangerous, but they're not useless. And in fact, there are a lot of clever people out there who have found uses for every bad thing that we would like to remove. And the web is this weirdly fragile thing where a program does not get to choose where it runs. It has to run everywhere. So once a mistake gets into the standard, it's going to be there for a long, 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 long time. So we're very much constrained in our ability to take things out. But you're not. I mean, you have the power to decide what this language is going to be, and you can select for yourself how you're going to subset it. And so you've got a power that we don't have, which benefits you tremendously. The worst feature by far in the language is the global object. It is the container for all global variables and built-in objects. And on browsers, it's the global object, or it's the window object. And the conflating of window and global is another of the sources of the cross-site scripting problem. So we can fix JavaScript. Hopefully in some future edition we can manage the global object and make it better. But we also have to fix the DOM, because if we don't do something about window, we haven't accomplished anything. We also have the hazard of implied globals. This was intended for the users to make it easy for them. So if they didn't understand variable scope, they could just ignore it, and all variables are global by default. That was good for the beginners, but it's really bad for the professionals. And so fortunately, JSLint catches all of those, so we can avoid that. Because of the current design of the language, we can't avoid global variables entirely. Occasionally you need, maybe one, maybe two. And so my feeling in that case is that they should be as rare as hen's teeth, and they should stick out like a sore thumb. So my advice is have very, very, very few global variables and make them uppercase so they really stand out. Now there's some controversy about this, and it's because of C. C has a goofy macro processor, which doesn't really knit very well into the language. So you're programming in two languages at the same time. And early on in C, people got confused about having these two languages interacting in the same program. So in order to make it easier to manage, they adopted the convention that the macros should be spelled in all uppercase and everything else is all lowercase. And okay, in the context of C, that made sense. When Java adopted those conventions, it kind of got confused about why that use of uppercase occurred. So global static variables were made all uppercase. But there's no reason to do that because it's all in one language. That confusion didn't exist. The Java type system sorts that stuff out for you. And then JavaScript adopted the same convention, and then most JavaScript programmers also adopted that convention to no useful benefit that I can see. So my advice is your constants aren't really constants, and even if they were constants, actually in ES5 they can be constants now. So you can have an object full of constants, and you can freeze it, and they will be constant. That's a good thing. But they don't have to be in all caps for you to do that, and making them all caps doesn't make that any easier to use. So my advice is let's use all caps for globals, because that's a bigger problem. And it actually is more consistent with C's solution in that C recognized we have a design error in the language, let's use uppercase to identify that. I'm proposing doing the same thing here. Another example is the plus plus operator, the auto increment and also the auto decrement operator. This one is much more controversial, but if you look at the problems in operating systems in trying to write secure systems, for years, it may be still going on to some extent, although not as much as it used to, Microsoft was plagued by buffer overrun errors. And it was really easy to compromise Windows by just working the code and causing an array to go out of bounds, and that would allow you to write stuff into arbitrary memory, and you can include programs there and then jump to them, and then you get to run. So it turned out a lot of that was due to coding practices based on optimizing use of ++. ++ allows you to do a lot of things at once, and so you can have one statement that's actually doing the work of several statements. And there's a satisfaction that programmers get from going, yeah, look at that, it's twisted. And, that turns out to be a really bad practice. And I found in my own case, it was a hard one to break. Particularly given my background, I did a lot of assembly language in my youth, and I still have those attitudes that when I'm writing, I want to make stuff go as fast as possible. And ++ is really an assembly language feature. It's not really a high-level language feature. It's an assembly language feature that found its way up into the higher level. And I now think it's counterproductive. And I tried to wean myself off of it. So I'm not going to try to write out those one-liners anymore. And I just couldn't resist. You know, once I go ++, and then it's comma, blah, 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 and I'm doing it again. So for my own discipline, I say, no, I don't trust myself to use that operator ever for any reason. And so I put an option into JSLint just for me, because I don't trust myself to use ++. And people write to me all the time complaining, why are you saying that? And it's like, why do I care? You know, you can turn it off. You know, I put that on there for me, but they still want to argue about it. And they're saying, because, you know, you say, write x plus equal 1, you know, when I could write x plus plus, which is so much better. It's one character shorter. Why can't you see the advantage of that? And go, well, wait a minute. First off, you're confused, because it's actually equivalent to ++ x. So, you know, one of the dilemmas about that is it's really easy to swap the pre and post thing that it does and get it wrong. And I find most of the people who are defending that practice do get that wrong. And so I look at it in terms of the reward benefit thing. Okay, the benefit is I save one character only when the thing I'm incrementing is a constant and it's 1. And I go, that's just not a benefit. Even if it weren't associated with all those security problems and all the bad practices, it's not worth it. From my point of view, it's not pulling its weight as a language feature. So in my view, it shouldn't be there. Now, will it ever leave the language? No, I think we're stuck with it. But you don't have to use it. And whether you use it or not, I don't care. It's none of my business unless you're working for me. But most of you aren't and probably never will, so it's really up to you. But if you're asking me, I'd say no, += 1 is just fine. You know, you got a variable, you want it to be 1 bigger, that works. So, you know, people get all, it's like, you know, coming up with rules for how to use scissors. You know, scissors are a useful tool, but they can be dangerous. And so when you're walking around with scissors, you want to be careful, you want to hold them right and not be reckless. And I get letters all the time from people who say, yeah, I take the scissors and I run like this. And I haven't gotten hurt, you know, so I should be able to use ++ and with and all that stuff. And I don't know, it seems a little childish to me, you know, that we're trying to be professional. So in our profession, we make trade-offs. You know, we look at cost, we look at benefit. I think programmers make more decisions in a day than pretty much any other profession. We're constantly making decisions, hard decisions, balancing off one thing versus another. And if we do it right, the programs turn out really well. And if we do it badly, the programs turn out poorly. And it's very hard at the moment that we're making the decisions to know what the right answer is. And sometimes we never find out what the right answer is. But part of the craft of being in this profession, being professional programmers, is to try to get better at making those trade-offs. And I think this kind of programming style is a meta example of the same thing. So bugs are an inevitable hazard in programming because we make so many decisions. The likelihood that we're going to get them all right every day is just really low, and we struggle with that. And so the hard thing about this craft is overcoming our human frailties and our inability to keep complex systems in our little brains and make all this stuff work anyway. So anything that we can do to shift the odds in our favor, I think that's a good trade-off. And I think there are things we can do in coding styles and in language subsetting which improve our ability to do that. So programming styles should be conventions that promote good trade-offs. And among those conventions, we want to see avoidance of the ambiguity, confusion, and potential errors which plague us and our customers and everybody else. So that's what JSLint is for me, for this language. This is a wonderful language. It has become my favorite language, which I never expected that. I never thought I would be the JavaScript guy. 10 years ago, nobody wanted to be the JavaScript guy. And it really surprises me now that I can get a crowd like this to come out and hear me talk about JavaScript. Like, this can't be happening, right? This doesn't make any sense. So I don't know what you've heard, but I am a deeply flawed human being. And writing good, high-quality code in any language is hard. And writing it in this language is especially hard because of all the bad parts, because of all the traps that are set for you there. And I find that JSLint helps me to do this stuff better. So I'm much more confident. JSLint's role for me is as my proofreader. If I were writing prose, it would be my editor helping me to write good stuff. And so I'm not mad when my proofreader shows me that I misspelled something. I'm grateful. Good. I'm glad that the book didn't go out with that misspelled. I feel the same way about JSLint. I really don't want my code going out with that stuff in it. And so I use it before I test. It's part of what gives me confidence. Now, it doesn't guarantee that I'm bug-free, but it improves the odds considerably in my favor, and so it's worth it for that. What's the future of ECMAScript? I have no idea. One thing that we learned from the ES4 project was we should not be pre-announcing anything that we haven't figured out. That just doesn't do anybody any good. And at this point, we really haven't figured anything out yet. There are some things that I would like to see in the language. Primarily, I want to improve its security. I don't care about anything else. If we can just do that, I will be very, very happy. I think that would be the best thing we could do for this community. There's a lot of pressure on us to do a lot of other things, too. And whether that's good or bad, I don't know. Again, I would apply some trade-offs to it. I would tend to be in favor of anything which could substantially improve the readability of programs. If we could more clearly represent our intention in a way that not only the machine can understand, but other humans could understand, I think that would be a huge benefit. I don't know what that'd be, but I'd be open to that. I'd be open to anything which significantly amplified the abilities of a programmer. So something that we're doing in 10 lines now, you could do in 1. You go, yeah, that's a good trade-off. I could go for that. The ability to do something we can do in 10 lines now in 9, I don't see much of a payoff there. There's got to be something more going on than just a tiny increment. I mean, that would put you in the same thing as ++. I don't see that as a big enough improvement. But what actually happens, it's too early to say yet. When we finished ES5 in December, at that time we predicted that we wanted to publish the next one in 2.5 years. So, at this point, I still have no idea what we're going to publish at that time. I'm hoping that we can make the standard a lot easier to read than it is currently. The ES5 standard is much easier to read than ES3, but it's still way too hard. And the thing I'm trying to get the committee to accept is that we'll write the specification of the language in JavaScript. So that we'll take all of the primitive operations that are in the language, write them in high-level JavaScript. It may actually be executable, so that you could have a meta machine running in JavaScript, written in JavaScript, so you could actually test the specification. I don't know if we'll do that yet. We haven't fully explored all the problems in doing that. But I think that would have a huge benefit to this community, because now we could all go to the same place to understand how the language works and actually have a good chance of understanding it. So I think that would be good. The interesting thing about JavaScript now is because of its success in the web, it's now finding success in other places. So it's not just about browsers. We're now seeing some really interesting work happening in servers now. So server-side JavaScript looks like it's going to be a huge thing. And I'm really excited about that possibility. We're seeing JavaScript now becoming the language of mobile. All the smartphones that all the smart kids have are all using JavaScript. And we're starting to see it now find its way into consumer electronics devices. They've been flirting with Java for a long time. It hasn't really been working out. JavaScript's really working well there. So, that sort of invites a question, what changes do we need to make to the language in order to make it work better in those venues? Does it need new features? I don't think it does. I think just as it is, it's got everything they need. Streamlining the language would help a lot in mobile. If we could take out some of the cruft, then execution gets a little easier, and that means that you have a better battery life, and that'd be a good thing. But again, taking stuff out of the language, even bad parts, is really hard. So on the other side of that, you got the kitchen sink. There's a lot of interest in taking every feature that you've ever seen in any other language and, hey, let's put it into JavaScript. And I hope we don't do that, or at least not very much. It's too early to see if we'll do that again. ES4, in my opinion, tried to do that. ES5, I think, was a better standard for avoiding it. We'll see what happens. In my view, all that's really going to accomplish is dumb the language down. That there are some evolutionary features in JavaScript. Its use of functions combined with prototypal objects is just this ingenious mixture of features. And we haven't completely figured out how that works yet, but those of us who have made some progress on that are pretty happy about it. There are a lot of people in the community who haven't made that leap yet, and so they're still looking at how can we make it more like Python? How can we make it more like Ruby? How can we make it more like Java? How can we make it more like Fortran? I'm thinking we shouldn't do that. I don't think we need to, but we may yet, so we'll need to watch how that goes on. Really interesting development is the influence of JavaScript on new languages. We're starting to see new languages being developed based on JavaScript. So starting with that core idea is grow it. One of my favorite along those lines is a new little language called CoffeeScript, which takes the good parts, just not even all of the good parts, but a nice little language, and comes up with groovy new syntax for it, which is minimal. So it's almost like dandelions. It's just a little fluff of programs that do everything that conventional JavaScript programs do. You can't do anything in that language that you can't do in JavaScript, so it's all cosmetic. So I don't know if all or much of that will find its way into JavaScript, because I'm not sure there's enough of a payoff there. But just as an experiment, as a design exercise, I think it's a brilliant piece of work, and I'm excited to see stuff like that happening. Also, it's interesting to see the influence that JavaScript is now having on older, badder languages. For example, Java got generics fairly recently, and they did a really bad job of it, but they got them now. And JavaScript's always been generic. Everything's generic in JavaScript. So Java's kind of catching up. They're talking about putting lambdas into Java now, be more like JavaScript. We'll see how they go with that. They'll probably find a way to screw it up, but it's interesting that they're talking about it at least. How can they be more like JavaScript without admitting that that's why they want that? But that's what they do. JavaScript has become an influential, important language. Who would have thought? Wow. So finally, I'll leave you with one thing. Write well. Write good programs when you're writing programs, particularly in JavaScript. When we started with this silly language, we didn't know that it was possible to write good programs in it. In fact, a lot of us were pretty convinced that it wasn't possible, so it wasn't even worth trying. If you could get it to work, that was about as much as you could hope for. It turns out, when you understand this language, you can write really good programs. You can write beautiful programs. And in fact, it's necessary to write good programs because it's so easy to write bad programs in this language that you really have to be intending to write good ones or it's not going to work out well. So that's the challenge, write good in this language. So I'm glad you're with me here at the end of all things. Until we meet again, thank you and good night.